Somewhere past the orbit of Neptune, a signal reached a NASA control room at 3:47 in the morning, and the engineer on duty didn't call his supervisor first. He called the director of planetary defense, because what Voyager 2 sent back that night wasn't telemetry. It wasn't a status ping. It was something structured, deliberate, and terrifying in its simplicity. Within 6 hours, 3 space agencies had gone quiet. Within 6 days, the story had vanished from every news cycle like it never happened at all. But it did happen, and what Voyager 2 discovered out there in the dark didn't just rewrite what we know about deep space. It handed humanity a warning we may not have the time left to properly understand. Stay until the end, because the final transmission is the part they really didn't want getting out. Voyager 2 has spent almost 5 decades doing exactly what it was built to do, drifting silently outward, past the gas giants, past the heliopause, into the cold nothing of interstellar space, sending back faint whispers of data on a power system that should have died years ago. It was never designed to think, to decide, or to notice anything on its own. It carries no artificial intelligence, no onboard reasoning, nothing capable of independent action, which is exactly why what happened this spring broke every assumption NASA's engineers had built their careers on. On March 9th, without a single command being issued from Earth, Voyager 2 altered its trajectory. Not drastically, not violently, but with a precision that made the correction look intentional, calculated, almost surgical. The onboard thrusters fired in a pattern nobody at the Jet Propulsion Laboratory had programmed, using fuel reserves that were supposed to be nearly depleted. When engineers pulled the logs, they found no command history to explain it. The spacecraft had simply decided, if that word even applies, to turn. At first, the working theory was a corrupted command buffer, some old dormant instruction from decades ago finally executing after a hardware fault. It was a comfortable explanation, and for about 72 hours, everyone at JPL believed it. Then the second correction happened, an even smaller adjustment, aligning Voyager's remaining instruments toward a patch of empty sky roughly 4 light-years out, a region with no charted planetary bodies, no known stellar objects, nothing but background radiation as far as any telescope could tell. Except it wasn't empty. When the Very Large Array in New Mexico was quietly retasked to stare at that same coordinate, astronomers picked up an object that hadn't been there in any previous survey. Faint, cold, and moving. Not orbiting a star, not drifting with the natural rotation of the galaxy, but moving in a straight line, and that line pointed directly at our solar system. By late March, the object had a temporary designation and a very small circle of people cleared to discuss it. Its trajectory suggested it had been traveling for a long time, possibly thousands of years, on a course that would bring it through the outer solar system within a matter of months rather than centuries. Its size was difficult to pin down because it wasn't reflecting light the way rock or ice should. It was absorbing it, nearly all of it, the kind of surface behavior astronomers usually associate with engineered material, not natural formation. And it was decelerating, slowing down in a way that defies basic orbital mechanics unless something on board was actively controlling its speed. An object moving under its own power on a multi-thousand-year journey, arriving now at the exact moment humanity happened to have a functioning probe positioned almost directly in its path. The odds of that being coincidence were calculated at less than 1 in several billion. What made the discovery even harder to dismiss was how it had been missed for so long. Survey telescopes scan huge portions of the sky every night specifically looking for exactly this kind of object. Fast-moving, distant, potentially hazardous. Something on this trajectory, this size, this close, should have been flagged years earlier. When astronomers went back through archived survey data, they found faint traces of it in images going back almost 3 years, always dismissed as sensor noise or cosmic ray hits because nobody was looking for something that behaved the way this one did. It hadn't been hiding exactly. It had simply been moving in a way that made it statistically unremarkable until the moment it chose to become remarkable, decelerating just enough at just the right time to finally register as something worth a second look. Orbital mechanics experts brought in to review the data described the deceleration curve as one of the smoothest, most mathematically clean velocity changes they had ever seen applied to a natural body, the kind of curve you'd expect from a controlled engine burn. Not gravity, not atmospheric drag, not anything nature typically produces on its own. Then came the transmission everyone at JPL still refuses to discuss on the record. On April 14th, Voyager 2's instruments recorded a burst of structured energy lasting just under 9 seconds, arriving not from Earth, not from the approaching object, but seemingly reflected between the two, as if Voyager had briefly become a relay station in a conversation it wasn't part of. When decoded, the burst wasn't random noise or cosmic interference. It was mathematics, pure and unmistakably deliberate, prime number sequences layered over geometric ratios that matched no known transmission protocol used by any space agency on Earth. Whoever or whatever built that sequence understood exactly how to make first contact with a species that counts, measures, and reasons the way we do. It wasn't a greeting. When cryptographers at 3 separate universities independently modeled the sequence, they arrived at strikingly similar conclusions. This wasn't communication meant to be friendly, it was a countdown. The next anomaly came from an unexpected place. The golden record itself, the phonograph disc bolted to Voyager's side, carrying sounds and images of Earth for any future finder. For nearly 50 years, it has sat there as a symbolic gesture, inert, purely ceremonial. In early May, sensors detected a measurable temperature spike localized entirely to the record's casing, rising several degrees above the surrounding hull with no external cause and no internal power source connected to it. Engineers initially assumed instrument error until the spike repeated on a fixed 22-hour cycle, matching almost exactly the rotational period of the approaching object as calculated from its Lie T-curve. It was behaving like it was being pinged remotely from 4 light years away and somehow responding. By mid-May, governments that rarely coordinate on anything were suddenly on the same encrypted calls. Internal memos, later leaked to independent researchers, described the object using a term that had never appeared in an official document before: an approach vector, not an observation target. Approach vectors are calculated for things expected to arrive, not things merely being watched. Radio telescopes in Chile, Australia, and the Canary Islands were quietly retasked, away from their scheduled research to track the object around the clock. Public statements continued describing it as a routine interstellar visitor, comparable to Oumuamua or Borisov, unusual but harmless. Internally, the language was very different. One leaked briefing described the object's approach as, in the analyst's own words, inconsistent with any natural trajectory and consistent with a controlled deceleration profile. Behind that shift in language was a quiet but very real change in posture across multiple space agencies. Personnel normally assigned to routine mission operations were reassigned without explanation to a task force with no public name, working out of a secured wing of a facility that officially didn't have one. Budget documents obtained through public records requests months later showed an unexplained emergency allocation, tens of millions of dollars redirected in a single fiscal quarter toward what was labeled only as anomalous object tracking and response planning. Response planning is not a phrase agencies typically attach to a rock drifting harmlessly through the outer solar system. It is a phrase reserved for something that requires a plan, a contingency, a decision tree with actual consequences attached to each branch. Whatever internal models they were running them with enough urgency to pull real money and real people off other priorities almost overnight. For weeks, cryptographers at NASA and several allied agencies had thrown every known decryption method at the sequence and come up empty, partly because they kept assuming it had to be built on a framework similar to human coding standards. Then, on June 2nd, the mathematics embedded in Voyager's transmission was finally cracked, not by NASA, but by a graduate student in Seoul running the sequence through a pattern recognition model built for an unrelated astrophysics project, one that happened to treat the numbers as pure ratios instead of forcing them into a binary structure. The prime sequences weren't just numbers, they were coordinates, layered with a secondary encoding that translated, once mapped against known star charts, into a set of dates, specific, exact dates stretching from the current month into the following year. When cross-referenced against the object's projected trajectory, those dates lined up precisely with its closest approach to 3 planets in our solar system: Mars, Earth, and eventually Jupiter. It wasn't just an arrival schedule. Attached to each date was a secondary numerical value that, once decoded using basic radiation unit conversions, corresponded to an intensity measurement, and the values climbed steadily, higher with each date, peaking dramatically around the projected close approach to Earth. That's when a second, quieter signal was noticed, hidden beneath the primary sequence, easy to miss unless you were specifically looking for structural repetition. This second layer wasn't mathematical, it was almost linguistic, repeating a short cluster of tones in the same order over and over with only slight variation each cycle. Audio engineers who isolated and slowed the pattern down noticed something unsettling. The rhythm of the repetition matched, almost beat for beat, patterns used in early warning systems here on Earth. The kind of tonal structure built specifically to interrupt attention and demand it. Whoever or whatever built that signal understood not just mathematics, but psychology, the exact acoustic patterns that make a biological brain sit up and listen. It wasn't trying to greet us, it was trying to make sure we couldn't look away. As July began, the object crossed inside the orbit of Neptune and its behavior changed again. Its deceleration, which had been gradual and consistent for months, suddenly stopped. It settled into a fixed velocity, still inbound but no longer slowing, as if whatever process had been controlling its approach had completed its final adjustment and locked the course in place. Around the same time, Voyager 2 received one last transmission, shorter than the others, lasting only 2.6 seconds but far more energetic. enough that engineers briefly worried it might damage the probe's already fragile receiver. When decoded, this final burst contained no new mathematics, no new coordinates. It simply repeated 3 times the same Shorty numerical sequence that had opened every previous transmission, followed by something that had never appeared before, a single, isolated tone that audio analysts described as unmistakably urgent, almost alarm-like in its structure. Then, silence. Voyager's instruments have recorded nothing from that direction since, and every attempt to re-establish that same channel, using the same frequencies, the same alignment, the same listening window, has returned nothing but the ordinary static of deep space, as though the door that had briefly opened had just as deliberately been closed again. Independent astronomers who've continued tracking the object using publicly available telescope time note that its current trajectory, if unchanged, brings it through the inner solar system within the next 18 months, passing closer to Earth than any confirmed interstellar object in recorded history. Amateur observers with backyard equipment have begun independently confirming portions of the trajectory data, comparing notes across online forums that, until recently, were mostly used to swap photos of meteor showers. Several of them have noted the same detail that quietly unsettled professional analysts, that the object's brightness curve shows faint, regular pulses roughly every 11 hours, far too rhythmic to explain as simple rotation, reflecting sunlight unevenly off an irregular surface. Whether that proximity is coincidence, calculated observation, or something else entirely remains the one question nobody with access to the full data set is willing to answer publicly. What we do know is this. A 75-pound plaque of gold-plated copper launched in 1977 as a hopeful message in a bottle may have just received the first reply in human history. And that reply wasn't a greeting, it was a countdown, timed, deliberate, and aimed directly at us. If you've made it this far, do one thing for me, hit like and subscribe so you don't miss the follow-up the moment new data comes through, because whatever is heading our way, it already knows exactly when it's going to arrive. We sent Voyager 2 outward as a symbol, a fragile human gesture thrown into a void so vast that the odds of anyone ever finding it were considered essentially zero. For nearly 50 years that comforting math held. Then, this year, without warning, without command, the probe turned and something out there turned to look back. Scientists can debate the trajectory calculations, the decoding methods, the statistical odds of coincidence, and many of them are doing exactly that behind closed doors right now. But underneath the technical language, a simpler and far more uncomfortable question remains, one that no amount of expertise can fully answer. If something has been traveling toward us for thousands of years, patient, controlled, and precise enough to slow itself down to arrive at an exact moment, what could possibly be worth that kind of patience? Voyager 2 didn't just discover an anomaly UT past the edge of our solar system. It may have discovered the reason humanity was never really alone out there, and whether that reason turns out to be a warning we're meant to heed or an arrival we're not prepared for, one thing is now certain. Whatever is coming, it isn't drifting anymore. It's coming on purpose. And like and subscribe if you want to be here when we find out exactly what that purpose is.